Alright, now that you've run some experiments and you have a lot of different models available to you, it's time to start the evaluation process. So this is where you'll take the time to actually compare all of those different experiments and see which of your models has the best performance. Maybe you have some specific metrics, which we'll talk about in just a second. But this is where all of those different experiments that you've run with your hyperparameter tuning, maybe you've tried out different algorithms or data sets, and the experiments of your fellow ML engineers. So this is where we get together as a team and compare all of our experiments to see what meets our metrics. To do that, we'll take the models that we decide to actually really consider for evaluation, because sometimes as you look through the experiments, you can kind of tell which models won't really give you the results that you need. So that can weed out quite a few of the experiments, but the ones that you have remaining, you'll need to do some kind of test with them. So validate that the models at least answer the question that you're trying to solve for the business. And to do that, you'll look at some of those key metrics that I keep bringing up to determine how well the model performs. So you might end up getting a little creative with those metrics based on the business requirements, but typically they fall under some kind of performance measurement like these three. So the first, our AUC ROC curve, or the area under the curve receiver operating characteristics curve. This is a pretty important metric when we're evaluating how well our models perform. So when you think about an AUC ROC curve, the way that it works is that the ROC is the probability curve, and the area under the curve represents the degree of separability. So basically, it tells us how well the model is able to distinguish between the different classes of data we have. So basically, if you give your model some data, is it going to assign it the right label? Is it going to group it in the right class? And when we have a high AUC value, that means that the model has a really high probability of predicting the correct class for our data. So usually the ROC curve is plotted against our true positive rate versus our false positive rate. And this is how we figure out what that probability curve is of getting the correct class for our data. So that's one of the metrics you might look at. Another is a confusion matrix. So basically, you'll end up with this diagram that shows you how well your model can classify particular data again, except this is kind of a different visual format, but you'll see confusion matrices and AUC ROC curves usually together, because what a confusion matrix tells us is basically how well does our model group two or more classes. So this is kind of like an extension to the AUC ROC curve. And then finally, we have concordant and discordant ratios. So this is how we describe relationships between different pairs of observations. And what that means is that if, let's say, we have two customers and one of them has a really high purchase rate and they live in Nebraska for some reason, and then another user has a really high purchase rate and they live in San Diego or somewhere like that. So if these customers are supposed to be classified based on their purchase amount, they would be concordant. And if they were supposed to be classified based on their location, they would be discordant. So that gives us a general idea of how our data relates to each other and how well the model is able to make those relationships. So these are some of those metrics you might look at as you're evaluating your models. But make sure that as you go through the evaluation, that the team doesn't get distracted by those statistical problems and making sure the calculations are right. Make sure that the original problem is actually solved by the model. So that is a really huge metric that takes a little bit of the business insight while you're discussing the different models. And then this is truly where experiment tracking is invaluable. So again, remember every experiment is made of your code, data, and your model. If you have this model that's answered the business question and the performance is incredible, you probably want to know the exact data set that you used to train that model with and the code that you used to build the model. So instead of keeping track of experiments in like a spreadsheet, use one of those tools that we talked about in the last section. And once you've gone through the evaluation, you can rank your models and select some for deployment. So these might go to different environments that aren't production yet, and you can do some more testing to see how well different models use resources, or if there's different ways you want to send new data to the model to test it out. And this is something that can also be automated within an MLOps pipeline. So you can run these evaluation scripts similar to how we did with the analysis scripts, similar to how we did with data ingestion and data integration. And you can set a threshold and pick the particular model or the experiment IDs that you want to be seen by an actual person. So you can always automate some parts of this evaluation step with MLOps. And something else just to note, a really good understanding of statistics really helps with this step because you're really looking at different metrics trying to figure out which of your models is the best and what you want to deploy to production.